मॉर्निंग स्टुडंट्स. बघा आता आज आपण बघणार आहे एक्सरसाइज 4.2 मधले रिमेनिंग क्वेश्चन्स ऑफ डेफिनेट इंटिग्रल. बघा 30 नंबर मध्ये काय दिले 0 to पाय बाय 2 डेफिनेट इंटिग्रेशन 0 to पाय बाय 2 x into sin x dx. तर याचे इंटिग्रेशन आपल्याला घ्यायचे आहे. बघा दोन डिफरंट फंक्शन्स, देयर आर टू डिफरंट फंक्शन्स. सो व्हाट वी कॅन डू, वी यूज द integration by parts. Okay, integration of u into v याला आपण अप्लाई करू. So what is it? 0 to pi by 2 x into sin x dx. By integration by parts, first function arithmetic function x, second function sin x is trigonometric function v. The integration, what is the integration by parts? Integration of u v dx is equal to u integration of v dx minus integration of du by dx integration of v dx total integration dx. Okay, इथे अप्लाय केला काय होईल x into integration of sin x dx integration 0 to pi by 2 minus d by dx of u means x, then integration of sin x dx and total integration dx 0 to pi by 2. What is integration of sin x? Is minus cos x limit 0 to pi by 2 minus 0 to pi by 2. Derivative of x with respect to x is 1 and integration of sin x minus of cos x dx. Total integration limits 0 to pi by 2. Then what is it? Minus x cos x minus minus plus 0 to pi by 2. Here is limit 0 to pi by 2. Integration of cos x dx. Okay, so you put the limits, upper limit and lower limit. So minus pi by 2 cos pi by 2 minus 0 plus integration of cos is sin x, and by putting the values of limit, what it will be, it is coming to 0 plus sin x upper limit sin pi by 2 minus lower limit sin 0, so it is equal to 1. So integration of 0 to pi by 2 x sin x dx is equal to 1. This is the value of definite integral. Now question number 14. Integration of x into tan inverse x dx and definite integration, its limits are 0 to 1. What is the value of this definite integration? Now I denote it by r, capital R. Integration I from 0 to 1 x into tan inverse x dx. So I use the integration by parts. Inverse function LIATE, in that sequence I, inverse function is first function and arithmetic function is second function. So first function is tan inverse x, second is x. So what it will be, tan inverse x by integration by parts. Apply the integration by parts here. Okay, here also I applied the integration of u v integration by part. What it will be, tan inverse x integration of x dx minus integration d by dx of u means tan inverse x integration of x dx total integration dx. So it is 0 to 1. What is the integration of x? Is x square by 2 tan inverse x 0 to 1, limits are 0 to 1. 0 to 1 tan inverse x, derivative of tan inverse x 1 upon 1 plus x square into integration of x is x square by 2 and total integration is dx. So upper limit, by putting the limits, what I get, 1 square by 2 tan inverse 1 minus 0, okay, minus 1 half integration x square upon x square plus 1 dx and 0 to 1. Now I add 1 and subtract 1 here. So by dividing separately x square plus 1 to the numerator. So what is the value of this first term? It is coming 1 half into pi by 4 minus 1 half, and by separately dividing two integrals and get here 0 to 1 integration of dx minus 0 to 1 upon x square plus 1 dx. Okay, so pi by 8 minus 1 half x minus tan inverse x. Okay, its integration is tan inverse x plus constant of integration, but this is a definite integral, so we need not to add the constant of indefinite integral. So by putting the upper and lower limit, what I get? I is equal to pi by t minus 1 half 1 upper limit minus tan inverse 1 minus 0 minus tan inverse of 0. Okay, so what it will be? I is equal to pi by 8 minus 1 half 1 minus pi by 4 minus 0. So its value is 1 minus pi by 4 multiplying by 1 half. So I is equal to pi by 8 minus 1 half plus pi by 8. Okay, so pi by 8 is equal to pi by 4 minus 1 half. This is the final value of this definite integral. Okay, pi by 4 minus 1 half. Now next question 50 number is in a definite integration 0 to infinity x into e raised to minus x 0 to infinity. Okay, here 15 number 0 to infinity x into e raised to minus x dx. What is the value of this definite integral? So I denote it as capital I 0 to infinity x into e raised to minus x dx. This is the exponential function. Okay, this is arithmetic function. This is first function, exponential function. E. Exponential function is second function and arithmetic function is the first function. Therefore, by integration by parts, what I get here? Limits. First function x as it is. Integration of e raised to minus x dx. Limits from 0 to infinity. Minus integration d by dx of x. Integration of e raised to minus x dx. Total integration dx. Limits from 0 to infinity. So x integration of e raised to minus x is e raised to minus x upon coefficient of x minus 1. Log e value is 1, so need not to divide it by log e minus. So here I put the limits 0 to infinity minus 0 to infinity integration derivative of x with respect to x is 1 and integration of e raised to minus x upon minus 1 dx. So its value is coming minus 1 as it is. Upper limit minus lower limit infinity e raised to minus infinity minus 0 into e raised to 0 minus plus and integration of e raised to minus x is e raised to minus x upon minus 1 and 0 to infinity. So its value is infinity. E raised to minus infinity is 0. So first term is 0, second is also 0. The total value 0 minus 1 into I put here e raised to minus infinity minus e raised to minus 0. So minus 1 into 1 upon e raised to infinity minus 1 upon e raised to 0. So what it will be? Minus 1 e raised to infinity is infinity and 1 upon infinity is 0 minus e raised to 0 is 1. So final value is equal to plus 1. Okay, definite integration is equal to plus 1. Now, in second question, what are the examples of definite integral? Question number 2. Evaluate the following. Evaluate the definite integral 0 to 1 upon root 2. 0 to 1 upon root 2 sin inverse x. Sin inverse x upon 1 minus x square. Okay. Raised to 3 by 2 and dx. 0 to 1 upon root 2 sin inverse x upon 1 minus x square raised to 3 by 2 dx. So, what is the value of this definite integration? I denote it by I. 0 to 1 upon root 2 sin inverse x upon 1 minus x square raised to power 3 by 2 dx. So, here I could evaluate this integration by substitution. I put x is equal to sin inverse, okay, x is equal to sin theta. Okay. So by substitution I evaluate this integral, or what I can do here, I made some arrangement here. 0 to 1 upon root 2 as it is, sin inverse x upon 1 minus x square raised to 1 and 1 minus x square raised to 1 half dx. So this 1 half power means there is a square root. 0 to 1 upon root 2 sin inverse x upon 1 minus x square and root 1 minus x square dx. So put sin inverse x is equal to theta. Okay, so x is equal to sin theta and differentiating with respect to theta. Differentiating x with respect to theta. So derivative of sin inverse x is 1 upon root 1 minus x square dx is equal to d theta. Okay, and also limits, lower limit, upper limit get changed. If x is equal to 0, then theta is equal to sin inverse 0 is 0. And if x is equal to 1 upon root 2, then theta is sin inverse 1 upon root 2. So it is equal to pi by 4. So definite integration I is equal to 0 to pi by 4, new integral. Sin inverse x, what is the value of sin inverse x is theta upon sin inverse x value is theta. Dx upon root 1 minus x square, its value is d theta, and divided by 1 minus x square. So 1 minus x is equal to sin theta, 1 minus sin square theta. So the new integral will be 0 to pi by 2 theta, 1 minus sin square theta, cos square theta, and 1 upon cos square theta is sec square theta d theta. Okay. So now use the integration by parts here to evaluate the integral. So what it will be by integration by parts. What is its value? So I is equal to theta, first function as it is, integration of sec square theta d theta. So 0 to pi by 4 minus 0 to pi by 4 d by d theta of theta, integration of sec square theta d theta, and total integration is d theta. Okay, theta as it is. Derivative integration of sec square theta. Sec square theta is the derivative of tan theta. 0 to pi by 4 minus 0 to pi by 4. Derivative of theta with respect to theta is 1 into derivative integration of sec square theta is tan theta d theta. Here theta tan theta as it is limits 0 to pi by 4 minus, what is the integration of tan theta? Integration of tan theta is log of modulus sec theta minus tan theta. Okay, and sorry, integration of tan theta is log of modulus sec theta and limits from 0 to pi by 4. So put the values of upper and lower limits. So what is the value of integration pi by 4 and pi by 4 minus log of sec pi by 4 minus lower limit 0 into tan 0 minus log of modulus sec 0. So it is equal to pi by 4 into tan pi by 4 value is 1 minus sec pi by 4 is root 2, so log of root 2 minus log of 1 value is 0. So it is equal to pi by 4 minus 1 half log 2. This is the value of definite integral. Okay, pi by 4 minus 1 half log 2. Now see, definite integration 0 to pi by 4 sec square x upon 3 tan square x plus 4 tan x plus 1. So what we can do here? I denote this definite integral as I 0 to pi by 4 sec square x upon 3 tan square x plus 4 tan x plus 1 and dx. So first I use the substitution method of integration. Put tan x is equal to t. Then what I get? Its derivative is sec square x dx. So differentiate tan x is equal to t with respect to t. What is the derivative of tan x? Is sec square x dx. You are getting here dt. So numerator value sec square x dx will be is equal to dt. And if x is equal to 0, then t is equal to tan 0 is 0. If x is equal to pi by 4, so t is equal to tan pi by 4 and its value is 1. So definite integration I is equal to 0 to 1 dt upon 3t square plus 4t plus 1. So this is a quadratic integral. So first we can do here, take 3 common from the denominator and use the, or you can use the partial fraction to evaluate the integral. So what is the value? I is equal to 0 to 1 dt. I take 3 common from the denominator. 3 into t square plus 4 by 3t plus 1 by 3. So last term is equal to middle term upon this bracket square. So what is its value? Middle term is 4 by 3 upon 2 square. So 2 by 3 square is 4 by 9. So integral I is equal to 0 to 1 dt. 1 by 3 is constant, it taken outside. So dt upon t square plus 4 by 3t plus 4 by 9 plus 5 by 9. 4 by 9 plus 5 by 9 is coming to minus 4 by 9. 4 by 9 plus 1 by 3 minus 4 by 9. Okay, so integration I is equal to 1 by 3 0 to 1 dt upon this expansion is the square of t plus 2 by 3 bracket square multiply 3 numerator and denominator by 3. So 3 minus 4 minus 1 upon 9. So it is the value of 1 by 3 square. So use the formula of 1 upon x square minus a square. So its integration is 1 upon 2a is 1 by 3 log of modulus x minus a t plus 2 by 3 minus 1 by 3 upon t plus 2 by 3 upon x plus a t t plus 1 by 3 and limits from 0 to 1. So its value is coming 1 half log of modulus. Put the values of upper and lower limit. First I simplify the terms. T 2 by 3 minus 1 by 3 is coming to 1 by 3 upon t plus 3 by 3 is 1. So put the limits 0 to 1 in answer. So final answer I is equal to 1 half into log of 1 plus 1 by 3 upon 1 plus 1 minus log of 0 plus 1 by 3 upon 0 plus 1. So 1 half log 3 plus 1 4 by 3 upon 2. So log 2 by 3 minus log 1 by 3. So final value I is equal to 1 half into subtraction of 2 log 2 by 3 into 3 by 1. So its final value is 1 half log 2. Okay, this is the final value of definite integration.